Good afternoon. My name is Tomasz Jakóbiec. Thank you for having me here today. I represent the Rockwell Automation branch Katowice. What we do the machine and process automation, but the automation is not the topic I would like to discuss today. I have something different, which I think is quite bold. It's a thesis that in best teams, all engineers are architects, and how to get there. Basically, as I mentioned, I would say it's quite bold statement. I will try to protect the statement. If I will succeed or not, it's up to you to decide. But I still think there is value in trying to prove it and trying to defend this thesis. So, first of all, let's take a look on the importance of the software architecture. And let's see what may happen if we disregard the software architecture. And to back up this, I will use this real case study from the well-known Clean Architecture book by the R.C. Martin. And what we see here on this chart is a number of developers that were hired to work on certain software product. And for each subsequent release of this product, we see the number of developers is growing quite rapidly. So one may say it's quite a big success, because if the number of developers that are working on some product is so high, then it must be a lot of new functionalities delivered with each next release. After all these people are working hard on this product. So new functionality means a lot of new things that user want to have. So they are pretty eager to pay for this next releases. So cash flows to the stakeholders and also to the developers. Everybody are quite happy. So what we got here, it's a success story. The question is it indeed a success? And to decide if it is or not, we have to take a look on two more charts. This chart on the left side presents us the product size in the code lines. So how many code lines were delivered with each subsequent software release. And what we see here is quite disturbing, because what we see that starting at third release, there is not much a new functionality delivered with next releases. The code base doesn't grow up, so there is not much new features that users are waiting to get. And if you consider that the number of developers is growing up, as we've seen it on this previous chart, then for sure it's not a surprise that considering this both two previous charts, the third chart which show us the cost per code line is skyrocketing high. This is nothing good. This is in fact a calamity, a disaster. So the question is, where we are right now, I would say that in this case, as a result of very poor choices about the code structure of this product, that was full of unattended dependencies between the classes and modules, we end up with something that really confuses developers. And I have proof to back up this thesis. What I got here on this right side of this slide is a capture from the dependencies between the classes in the real existing software of one company that I will not disclose here. And generally, returning to these confusing developers by soft structure like that, it's never a good thing, confusing developers is never a good thing, because after all, when you confuse the developers, then it reduces productivity, it's harder to write and test the code, it lowers the code quality, it's easier to introduce a bug, it's hard to develop new functionality and not introduce regression in the old functionality, and it generally impacts in the wrong way our collaboration. And I think everybody knows that, even the ChatGPT knows that. If we ask them what will happen if we're confusing developers, then it will say all these things. So someone may say, okay, but no, right now we have a lot of new methodologies, we have a lot of new tools that for sure there is a way out of there. And unfortunately not, it's a trap. Because all these improvements in other areas, like project management, using continuous integration, development, whatever, do not help us much at all. Until the main problem is fixed, so the architecture of our code is fixed. In fact, and there is some kind of value in that, all these new improvements of our methodology, our tools, what they will do, they will only make this problem more and more visible, which is, after all, a good thing. Because then no one can ignore this, neither developers, neither managers, that we have a problem with the software architecture of our product. And again, to back up what I say, I would use this book, A Practical Approach to Large-Scale Development. This book was written by the guys from the HP. They had a problem with the software or the firmware for the laser printers. And they did everything what the new modern companies shall do about introducing the Agile, introducing the continuous integration development stuff, integrating many new things in their daily work, but they were not able to recover without fixing the architecture of the firmware. So, saying so many words about architecture, the question is what this software architecture is. And now I have here some textbook definitions. It's a set of important project-related decisions that shapes the software structure in the way that software supports selected quality attributes. I will later go to this topic, and other properties. And all these decisions shall reduce the number of people needed to create and maintain the software system. And if you watch carefully, you see that I never mention here a functionality, because the architecture has, after all, reduced, or let's say, reduced impact on the functionality. Let me give you an example. Let's imagine that we have a software that has a structure of big ball of mud, some kind of spaghetti code, and this software still can provide the right functionality. But the question is it testable? Is it easy to maintain? Is it easy to extend? So, saying that, let me return to these quality attributes and say what they are. The quality attributes, also known as architectural characteristics in some books, and right now the quite vogue definitions, describes the property of the system that is visible outside of the system, and there are non-functional requirements that defines overall quality and behavior of the software system. And they are all these abilities with names that are tongue breakers for the people who are not native speakers, like maintainability, performance, scalability, which software may have or may not have, and still may do the job. I mean, in the functional way. I mentioned that these quality attributes are non-functional requirements, but there is some kind of agreement that we shall not use this non-functional too often for few reasons, and one of these reasons is that they exist, these quality attributes exist with the context of some scenarios which are pretty functional. Let me give you examples. Let's imagine that we have some kind of web-based application, and we have a quality attributes which we name responsiveness. And this quality attribute has its scenario. It may have many of scenarios, but let's assume that it has one scenario, which is named response time under medium load. This scenario has some stimulus, which is data request. Of course, the stimulus have the source, and in this case, obviously, it is a web browser, and it also has some environment, which is, in this case, for example, medium server load, and of course, this has to have a response, so the data are back to the browser in less than half of the second. Another one quality attribute, maintainability, and scenario name is adding a new feature. In this case, the stimulus is just a new request for the new feature. Source usually is stakeholder/product owner, which represent the stakeholder. An environment, let's say that system is in production and there are active users. And response for this scenario is that there are no regressions in existing functionality and users which are already using this system are not impacted in any harmful way. So the question is how to discover these quality attributes which are important for my software. Unfortunately, we need to understand few aspects. We need to understand our business. We need to understand our technology. And most of all, we need to understand user expectation, how the user will use our software. So it gives us a little bit of hunch what shall be the best skills and knowledge for architects. So knowing just the technology may not be enough to figure out what are our quality attributes. But how we can do this in real life? We may take a look on our use cases, our functional use cases. And then, for almost every single functional use cases, we will be able to get a scenario for quality attributes. And that's why we will discover quality attributes. For example, if we need to create the software that some web-based software and we need to get the data to our browser, then of course we need to know how fast we will want to do this, how responsive we will gonna be, and how many times we may fail. All these are non-functional but important things which we named quality attributes, and they have the biggest impact on the architecture. So what are the other things that obviously impacts the architecture? I mentioned quality attributes, which surfacing in business goals, but also business goals may give us another kind of constraints that we have to consider. For example, we have a budget. So some architectural solutions that requires a lot of resources may not fit into our budget. So we need to also consider that. On top of that, some business goals for our application will also give us some functional requirements which will have impact on the architecture. I said before that usually the functionality has limited impact on the architecture, but yes, some functionality will have impact. Let's imagine that we need to create some application that will store the data. After all, it will imply that this application, this architecture of this application may need to contain some kind of DBase engine to accommodate this requirement. So what are the other things that impact the architecture? For example, some architectural rules. Let's say you will not call the DBase engine directly from the graphic user interface, or you will not implement business rules in graphic user interface. That are the rules some kind of heuristics that are well known that we need to also consider when we're designing our architecture. So what else? For example, technology. Let's imagine, let's move back, for example, maybe 20 years, it's too much, but 15 years back, where the popularity of the open source operating system and tools were not so big as today. So implementing then, for example, a microservices architecture with having multiple copies of operating system, which every single license were paid for the use, was completely rubbish because it was too expensive to do this. Today, we have open source operating systems, open source tools, so going for the microservices is not a big issue. Of course, architect skills and knowledge, that's quite obvious. Team skills and knowledge is also quite obvious, but organization, maybe not so obvious. I think you may be aware of something which is named Conway Law, and Conway Law says that organizations tend to create the architecture in the same way, structure in the same way as the organizations are structured itself. So if there is a wall between two teams, and we will split a work between the two teams, then for sure we will have two different modules which are assigned to both of these teams, which are separated by the wall. So architecture also, the team organization or teams organization may also impact the software architecture. But of course, there are ways also to use this Conway Law to work for our favor. So far, I hope we learned that architecture is a set of decisions which mostly are compromises. About software structure, decision that takes into the consideration quality attributes, which I mentioned before, architecturally significant requirements, so these functional requirements which impacts the architecture directly, as I mentioned about this DBase, for example, engine, some rules, and other constraints like business constraints. What is important to underscore here, that mostly architectural decisions are compromises. So there's never a situation that is win-win always. So it's very important to document these decisions. Because now, until we do not have stated clearly why we made such a decision, then it's very easy to try to invalidate or challenge every single decision. Because someone who doesn't know why will see problems and mistakes everywhere until they understand why we get to some compromise. We decide to leave something out to get something other thing in our architecture. So always please document your architecture, especially thinking about why. And there is a very simple way to do this. A format how to document these decisions is called architectural decision record, and you can easily find over internet which data or which type of information we shall put into this record. So at this moment we have our decisions, we have our quality attributes, we have our requirements, functional requirements that will have impact on the architecture. We have our rules, our constraints. We already document everything. And there is a moment and time to select the structure of our software. The question is there any help to do that? And yes, there is a help. And this help is called architectural patterns. And let me jump to this. What are the architectural patterns? And again, I will use very formal definition first, and then I will speak more plainly. An architectural pattern is general reusable solution to a commonly occurring problem in software architecture with a given context. And saying in plain language, it's something like well-known design pattern, but it has quite a wider border scope. And there is many of architectural patterns currently, and new ones are being discovered as the business environment changes, as technologies changes, things that we couldn't done before, now we can do. So the new patterns are emerging. And I would say that developers shall be, and I think most of us are, familiar with the most basic architectural patterns, for example, layered structure, and more of this architectural patterns can be found in the books. What kind of books? I would say that almost every single book that is related to the software architecture will provide us at least some kind of catalog of architectural patterns. I bring here 3 examples, not because they are well known and easily to buy anytime, because there are also other books, but not so easy to purchase, I would say. Especially, I would like to put focus on the fundamental of software structure. They have pretty nice list of architectural patterns with well described, with all pros and cons. So right now we know that there are some books, and over internet you can also find the architectural patterns, but the question is, which one of these architectural patterns will fit best to my application? So there is another one, pretty nice process to do this, and it's called decision matrix. And what we do, we return back to our quality attributes and quality with the scenarios. We return back to our requirements that impacts the architecture, and we take selected architectural patterns and we evaluate them against all these quality attribute scenarios and requirements. So we will find that some of these patterns will support some quality attributes, and some others, contrary, completely not. Some other patterns will be neutral to these quality attribute scenarios and requirements. And doing that, of course, we may find 1 or 2 or maybe a little bit more such architectural patterns which will fit our needs. So they will be best for our checks. And at this moment, I would like to do small off topic, if I may, because what we did was some kind of architecture evaluation process. And this is very important thing to say, that this architecture evaluation is not a one-time activity. So, of course, we need to start with some idea about our architecture, but it's not that we shall leave it as it is and just do another 10 releases and everything will be fine. Unfortunately not, and I think we all are aware of that, then the code and architecture that is left to itself will erode, so we'll lose the ability to support these quality attributes. For example, with the time will happen less and less extendable or less and less testable if we don't care about that. So for time to time, for example, to planning every single next release, we shall reevaluate our architecture. Again, take our quality attributes with the scenarios, take the requirements that have an impact on the architecture, and get our architecture, our shape of code, which we currently have in our Git or whatever, and evaluate again. And believe me, if you do not have very sophisticated methodology to develop your software, you will end up with a list of improvements doing this evaluation. I did it a few times and always end up with this. So I will end up with a list of improvements which are directly the quite nice refactoring backlog. And usually there is an issue. The developers came to managers with this proposal. Guys, we need to do refactoring in our code. But how to prove it that it's worth to spend the time and money? So this is a very elegant process that you will have a background. If we will not do these improvements, then soon we will lose this and this quality attribute. And it will have an impact on our future development. So returning back to the main topic, we have already selected the structure. So we might jump to the coding. No. Before we will jump to the coding, I think we shall model our architecture first. Of course, modeling helps establish common wording, share intentions between team members and teams, manage complexity by presenting different details with different views. So we don't need to put everything on one diagram. We may have different diagrams with different level of details. And of course, it allows us to split bigger problems into smaller ones. I think everybody knows that if we have a big problem, the best way to deal with this problem is to split this problem on smaller problems, easier to be solved, and then one by one, ignore them all. Then we may, of course, conclude the quality attributes if we still support them or we do not support them. And then I would like to underscore that tools for modeling are for free. I think most of you is familiar with the plant UML. It's a language that allows us to write simple structures of code that later, with the tools like Graphics, can be transformed into nice-looking diagrams. We can have these diagrams integrated with Doxygen. We can keep these descriptions together with our code into within a repository. So the tools, basic tools for modeling architecture are free. But what is not free is time, which we will spend on doing the modeling thing and generally architectural works. So the question is, how much time we would like to spend on doing the architectural works versus the other works we do in project? And to answer this question, let's see what will happen if we will do too less or too much architectural works in our project. What I got here is a diagram that is based on the real data gathered by the researchers and published in the well-known books. What they did, they queried the several companies about this information, how much they spend on doing the works, the architectural works, and how much they spend the time doing the code reworks and fixing the code to finally works as it shall be expected. So what they found is when we do a very little architectural works, I think it is not surprise. Then we will spend a lot of time doing reworks. On the contrary, if we will spend a lot of time doing the architectural works, then we will spend really little time of doing reworks. But this effort and time we spend and money we spend on doing the architectural works to the full extent may not balance us the savings we have on doing the very little reworks. So there must be some middle ground. And yes, it is. And I just put it around 20%. So if we spend 20% time of our project time on doing the architectural works, then we will benefit the shorter project time entire. But what I would like to say is that this 20% is not always a 20%. It depends. So the sweet spot is not always at the 20%. It depends, and what was found by researchers is it depends on the project size. If the project is small, then it usually is about 5 up to 10% time we spend on doing the architectural works will benefit us the rest effort we spend on the doing reworks. In case of big projects, it could even go higher, up to 40%. So the next question is where we shall start doing these architectural works. And to answer this question, I would suggest following the risk-driven approach and analyze the functional requirements, constraints, and quality attributes using a pattern. State has consequences. What kind of? Let's see example. Let's assume that state is the database contains sensitive information about the customer, and this state may have consequences. That data breach may leak sensitive information, and this is the risk to the stakeholder. Another one state, for example, we have some embedded application. Application layer directly uses the hardware, and the consequences of this is that we cannot easily move to the another type of hardware because application code is hard to port. And this is also risk to developers. And then if we have such lists, we will prioritize it. And then what we shall do, if we have a risk, we shall consider a technique to reduce these risks. What kind of techniques? For example, we may use and apply architectural pattern or design pattern to solve well-known issues. We can do modeling. In case of security risks, we may use the security analysis. Having this model, we may do the risk storming technique. It's quite interesting thing. We may read a little bit more about this under this link. And I think also in fundamentals, there is a chapter which quite well describes this technique. We can do prototyping. And we can do any other activities that will, at the end, reduce these risks, which is related to the architecture, below any other project risks. For example, doing all these things, I reduce my architectural risk below the level that right now the biggest risk in my project is something related with the project management, maybe with the budget, maybe with the team availability, maybe with the hardware, which maybe I don't have right now. And when we get to this point, only thing which we shall do as the architects, we shall monitor if any risk related to the architecture, which will not spike us above any other type of risks. At this moment, you may have a concern that all what I'm saying here about this architectural works is after all against the Agile, because it seems like a big design up front. The question is it really against the Agile or not? Please remember that Agile, after all, is about reducing the risks that things will go wrong for too long. That's why we have sprints, that's why we have these feedback loops to figure out that we are going in the wrong direction as soon as possible. And what I'm saying is also about reducing the risks. And there is no problem to do this all activities in the incremental, iterative way, starting from the biggest risks. And now, after all, saying that, I would like to return to this my bold assumption. In the best teams, all engineers are architects and how to get there. And let's see how it may looks in many of organizations that we have very traditional division of roles. We have separate role for architect and, of course, separate roles for developers. And there is one-way relation between them. So architect speaks, and developers obey and implement the architecture, better or worse. So this is something that causes problem, because when one side speaks and second only listen, the outcome will be never good. And in fact, it's quite agile against agile, because team, which has no impact on the architecture, is lacking of necessary cross-functionality to do the job. So what we can do about the situation? I think it's quite obvious thing that we need to tear down this wall and integrate architect with the team. And this is a challenge for the architect. Because right now, the architect is a part of the team. Of course, the architect still can be part of some architectural entity, architectural teams. They still have their meetings and do their things. But after all, the architect is a member of the team. And as a result of that, development follows the architecture, and as it shall be, but also architectural response to development in the close feedback, as we see here. What is even more challenging for the architect, that right now, as the architect is a member of the team, the architect mentors the team members. So the team members gradually learn how to step into the architect role, at least partially. And what it gives us, that we can delegate responsibility down from the architect, which is only usually one, or there is number of architects is limited. We can delegate this decision making down to the team, as right now the team also owns the architecture, so they feel more entitled to work on the architecture and supports the architectural effort. So it gives us this huge benefit that all decision making speed ups in this case. So that is a challenge for for architect. But there is also, and there are also challenges for developers. But before I will jump to the challenge for developers, I would like to remind you, perhaps you know that, this famous sentence about things we know and we don't know. So there are things we know that we know, just we know. But there are also things we know that we do not know. But then there is oceans of things that we do not know that we do not know. And this is this pyramid. There's always more things that we don't know that things we know. And there is a difference between the knowledge deep and knowledge wide. And let's see how it looks like for developers and architects. Developers need to have a deep knowledge about something to do their daily job. You need to have a deep knowledge about the programming language you are using. You need to have deep knowledge about the code base you are using. You need to have deep knowledge about the tools you are using, because if not, then you will not be able to do your daily job. It's like that. But for the architects, it's even more beneficial to have a broader knowledge in this area, that things you know that you don't know. Because it's beneficial to know that there are options. There are other options than we usually take. And I may not be expert about these options, but it's enough that I know that there are other options and what they are, and then I can learn about them more when I choose one of them as I go. So the question is how to do this switch between this knowledge deep up to knowledge wide. I would say that we shall develop ourselves. For example, what we do in Rockwell, we're using this 70-20-10 learning model. How it works, we assume that each of us shall spend up to 10% of our time on formal education, which is reading books, taking formal courses, taking a part in events like that, like today. And then we spend about 20% of our time on mentoring. So we using more experienced engineers in our team to learn a little bit more. As we have right now the architect in the team, then we also may, let's say, use this architect to develop ourselves. And I'm not telling just about the daily work, what we do in our job. But I'm also talking about the things that we, for example, do at home if someone has a software-related hobby. For example, is writing some code at home. It's not a problem to bring this code to work and see and show this code to more experienced colleagues and talk about this code, talk about this architecture. So generally, we also learn by doing, so applying all this knowledge. All this knowledge we learn from this formal education, books, courses, from mentoring to our daily job. And why this self-development is so important? I clearly understand that there is no ambition for every single developer to be an architect. It's clear. There are different roles we can do as the software developers. Not everybody need to be and want to be architects. But I would like to point you to a situation that may happen if I will not develop and I will just stay as I am. I would say that this kind of trap is best described by Abraham Maslow, who said once that if the only tool, if you not develop yourself, if the only tool you have is a hammer, you tend to see every problem as a nail. So I really urge you to develop yourself and don't be this sad man who has only hammer in the toolbox and is smashing all problems with this hammer all day long, and their code is full of singletons from beginning to the end. So be a man who has many tools in the toolbox, even if you consider that mastering all these different tools will take years, or maybe even never happen to the full extent. So that's all from my side. Thank you for your time, and please have a nice conference.